Hello, I'm Simon Turner. I'm the National Workshop Manager for Canal River Trust. I'd like to welcome you to Bradley Workshop here in the West Midlands. This is one of the two sites that we have where we make lock gates for the Canal River Trust, with the other one being Stanley Ferry in Wakefield in Yorkshire. What I'd like to do is take you through a tour of how lock gates are made, the processes, the tools, the equipment and everything else involved. So every year the Canal River Trust will change up to 150 lock gate leaves. That process will start 18 months in advance, where we identify which gates need to be changed. The next steps will be lock gate technicians will go out to each site and take measurements and surveys of those lock gates to understand requirements. After that, they'll be transferred into the drawing department, where accurate detailed plans are produced, which allows the gates to be made. Once that has happened, we produce a cutting list. The cutting list is of the timber that is required to make the gates. So we'll take you through now and show you that process.
So the first step of the process, really the most important part, is us carrying out and doing the surveys of the lock gates. Now the purpose of that is for us to check measurements against existing drawings, but things have changed over 25 to 30 years. So we don't just want to rely on that old drawing, we want to go and check on site. So they'll use the drawing, they'll use how the gate sits, and they will take new measurements to come up with a survey. As you can see, it's quite technical. You know, the tools that they'll use to do this are really basic, and the reason we do it this way is it reduces, first of all, the cost of dewatering the lock, but also the impact on our customers. So if you can imagine, to do it in the dry, we'd have to dewater the lock, huge cost, a whole set of stoppages. We'd be doubling the stoppages that we'd need to carry out. So one of the main tools is a staff with a foot on the bottom that is used to identify the measurement from the sill, from the bottom of the gate up until the collar hole. And that can be quite challenging because they may hit a brick or a block or something else that's on the bottom of the canal. So we have to really sort of make sure that we've got that right position. As you can see, it means a sort of hanging over and leaning over, and as you can see there, this has a harness on to stop her from falling into the canal. So the other aspect we need to look at is the pitch of the gates. So lock chamber walls are never straight and plumb and level. So we have to determine what that pitch is to be able to determine the pitch of the gate. Now currently that is done, as you can see, by leaning over the lock edge with a level, and to take the measurements to determine the angle of the wall. So not the greatest way of doing it, but really, really important that we get that measurement right. So all in all, we have to take over 30 separate measurements for each lock gate leaf. That would include the collar hole, the length of the balance beam, the angle of the mitre gates, lots and lots of different measurements that are required. So we want to move that forward, we want to make it safer, we want to make it quicker, we want to make it more accurate. So we've just invested in laser pointing equipment. So this enables us to point a laser at a set point on the gate and to the next point and take accurate measurements and accurate angles. All of that information then can be transferred into the computer aided design packages, the CAD packages, that enables us to more accurately and safely take the measurements that are required. So this sort of moving forward is new technology. This investment in the technology is absolutely crucial of us moving forward in lock gate production.
Okay, so this is the drawing office at Bradley Workshop. So once the site survey has been completed, all of that information comes through to be drawn in CAD. So it's computer aided design. So we have for a long time relied on a 2D CAD approach. So it produces a flat drawing with not a huge amount of information
in it, because a lot of the information was in people's heads. And what we want to be able to do is take that out of people's heads and get it down onto a drawing. So as you can see here, this is a typical 2D general arrangement drawing that's being worked on. So this is a lock gate which is on the Worcester and Birmingham Canal. But the next step, and where we're moving to now, is 3D design. So this is 3D modelling, and you can see there what we're able to do is take a model of the gate once it's been drawn. We can manipulate it, we can turn it, we can ensure it works, we can ensure that it fits. So obviously gates are made specifically for that lock chamber, so if we get it wrong, it can't go somewhere else. So all of this is next steps and next steps in the process of us moving towards CNC, which is computer numerically controlled production. We've already started some of that with our plasma cutters, which we'll show you a bit later on, but we're also now looking at the next steps for CNC machines for lock gate production. So the guys do a great job, 150 plus lock gate leaves per year that they will have to draw and model and check and design, and if they get it wrong, the gate's wrong, so there's no pressure. So once the drawings are produced and they've moved to the shop floor, that's when the gate production starts. So it starts off with green timber being produced, English oak and Scottish oak coming into the workshop in its rough cut state. So the next step we have to do is to plane the timber. Now we're not planing it to make it smooth as you would like a piece of joinery. It's really to square and true the timber so it works well for the gates. So once it's coming into the workshop, it then moves onto the planing machine. So this is a two-sided planing machine. So what that enables it to do is to plane two sides at once, but it's a very old machine and only one of those sides works currently. The timber's loaded onto it and it moves through automatically, multiple passes, taking around about 5 to 10 millimetres off per pass. So once we've got the timber planed, what we'll do then is move it onto the saw here. So this saw allows the timber to be cut to its length. Big saw, and as you can see, safety is paramount. It says here, no hands, and that doesn't mean people have got no hands, it means you won't have any if you put your hands in this area. But it's a very, very large section saw, hence no hands. So the gates are made in a very simple way. So all of the joints are mortise and tenons. So there's a tenon cut which sits into a mortise. That's the main frame for the gate. So the next step after it's been cut to length is to pass it into the tenoning machine. So this is the tenon machine before it's been loaded. And if you have a look through there, we have two cutters, top and bottom. The timber sits on here, and these two cutters cut and form the tenon. Very, very efficient way of doing it. So once we've done the tenoning, the next step is to cut the mortises. So the machines we have for that, which is we'll move over to now, date back to the 1950s. So we've definitely had our money's worth out of that machine. So I'll show you how that works. Steve. So first of all, we drill holes in the timber. So this takes out the bulk of the material. As you can see, it's hand operated. So once the holes have been drilled, the next step will be for the mortise chisel to form the square. So it drills a square hole.
As you can see here, there's a four-sided chisel that's very sharp with an auger in the middle. The auger takes out the bulk of the timber and the chisel squares up the sides. So as you can see, we've drilled a square hole. And you can feel the wet in the timber because it's green oak, so it's not dried out. Not excessively wet, this one, but some of them you can actually squeeze out water. There's that much moisture involved, but it has to be green oak. Kiln dried oak would be too expensive and impossible to achieve. So this is the end of sort of the machining section. So once this is done, and there could be up to 25 of those joints per lock gate. So you can imagine the time that it takes doing it the way that we're doing it. But once that's done, we're then moving to the assembly side. And there's quite a bit of finesse there, even though with the big heavy joints and heavy timbers, there's a lot of finesse. So I'll show you some of the tools that we use from the assembly part of the process. Because we're using such big timber, we have to use big tools. Crocodile Dundee, that's a chisel. All right? And we don't use mallets. We use lump hammers. Some of the other tools are actually made for, we have them made because you can't buy them. Again, very big chisels because it takes a lot of effort on there. We're moving very much now into battery tools. So these are sort of 40-volt impact drivers. These are very powerful. They're used to bolt all of the joints and all of the plates together onto the gate. We have very large planers. Again, not the sort of thing you'd pick up from Screwfix. All it's quite specialist equipment. Big drills. And some very, very specialist pieces of equipment. So this is a chainsaw, jigsaw chainsaw. So kind of a very, very specialised equipment, a very expensive equipment. These kind of go for around about £6,000 for that machine, and that's used to cut the bulk timbers to their lengths as well. Big chainsaws, very large, and everything has to be electric or battery powered because we're inside the workshop. But there's also an amount of finesse. These are beautiful planes, used specifically for forming across the tenons. So the handle, you can see, is offset to one side, and basically has to stop you from punching the side of the timber as you go through. So there's an amount of finesse involved as well. The tools that we use are extensive. I would put it at £100,000 worth at each workshop of tools that we need to do the job and make the gates. So quite a lot of money involved in doing that. A lot of the machinery you see in the workshop is old. It dates back to the 1950s. We've had our money's worth. But we are at a point now of needing investment, and the trust is looking into that now to move into CNC machinery. And all of what we're doing is gearing towards that next step. So it's kind of an evolution. We've gone from hand tools to steam powered tools to electric tools. Next step is CNC tools. The gate components, there are huge amounts of different
pieces that need to go together to make the gate. So not just the timber, there is gearing, there is components, there is brackets. All of these things are required. So I'll take you to the stores, show you just some of the examples of the different sizes and pieces that we have to use. A very well kept stores, as you can see. So every gate is the same in how it operates. So it has a top and bottom hinge. So the hinges are very straightforward. So this is off a BCN gate. So this is the pintle. So this is set into the bottom of the heel. This is the cup, which is set into the bottom of the lock. The pintle sits in and it spins. Very straightforward. Where it becomes complicated is different canals have different styles, and it's part of the uniqueness of each canal stretch that we ensure that all of that is kept the same. Also from a cost point of view, if we were to try to standardise it, we'd have to do a lot of work, structural work to the lock chambers. It would cost us a lot more money. But some of the examples of the different ones that we have here. So this, for example, this is off the Wigan flight, and it is heavy, I do apologise. But that is set into the bottom of the heel. And the cup is sat into the bottom of the canal. Here, a different arrangement. This is Worcester and Birmingham. That is set into the heel by the joiners. And this section sits into the bottom of the canal. So whilst they're all the same, they're all different. And each canal is unique in the parts that it would be required. Some of the bigger ones we have here, the Trent and Mersey. So these are really the larger gates, as you can see, exactly the same principles. So the other important aspect of around the lock gate production is the gearing. So similar to the hinge arrangements, the gearing is unique to different canals. So here we have Trent and Mersey style, and over on this wall is the BCN style, and we have lots of in-betweens. Some of that gearing does transfer from different canals. So Trent and Mersey gearing becomes more of a common type gearing. BCN obviously across the whole of the BCN. But still a lot of different parts that need to be put together to enable the gearing to be worked. These are all cast, they're all cast parts. And they tend to last the life of the gate, but some of these components will wear and we'll change them. And we have a process of recycling gearing that can be recycled for use on new gates to reduce our cost and impact. The racks, so here we have a rack mechanism which enables the paddles to go up and down, in effect, is what they will do. And we also have reinforcing parts which are produced in-house. So these are around the bottom of the heels to protect them and to stop them from splitting. So lots of different parts that are required. And if you follow me around, I'll show you one here's one we prepared earlier. So here's a set of completed gearing. As you can see, the different cogs, the racks, the brackets, the plates, all that are required to operate the paddles on the locks. So everything that we see around sheet plating here is done in-house, produced by our teams. And a lot of that work is done on our plasma machine. The plasma machine is a machine that is CNC controlled. So this is an investment the Trust made sort of 12 months ago. So a lot of the equipment and parts that we previously bought in, we're now able to produce in-house. So as we said, this is a plasma cutter. So it uses compressed air and electricity to form the plasma, which then does the cutting. So some of the things that we will produce are these fender plates. So all of those have been cut. Previously we will have had to have bought them in or spent a lot of time drilling all of the holes. But the main reason is to produce L's and T brackets. So these brackets are there to reinforce the mortise and tenon joints, and there's a pair on each joint. So the minimum we would have is 6 sets on a small gate, and previously we were paying around about £60 each set. Producing them in-house we can do for £30. So we'll pay off the machine in 12 months, and then all of those sort of savings will transfer forward. So we have one machine. It produces parts for this workshop and for Stanley Ferry in Yorkshire.
So once the gates are completed, they're stored out on the yard and kept wet and watered to stop them from drying out and twisting, especially in hot weather conditions. Once the gates are ready to be installed, wagons will be sent to the workshop and they will be loaded with the lock gates, the lock beams, the gearing, all of the components required to install the lock gate. The whole process of making the lock gates, as you can see, is quite complicated and expensive. So basic lock gates will start at around £16,000 to make, up to large river gates that will be in excess of £100,000. So without the lock gates being installed and changed on a regular basis, canals would close. So it's a very key and important part of the work that the Canal and River Trust does.